Good day, I am Lay Angela Elgia and I am presenting a game theory equilibrium analysis on volleyball. To start off, what is game theory? It is a mathematical method of decision making in a situation or games to determine which strategy would be best for the participant or player to use. Do keep in mind that the games contain a set of rules and outcomes. The main idea of the game theory is determining which best strategy should the player use to different strategies its opponent use in order to receive the maximum payoff. Before we jump straight into the discussion, let's discuss first the terms you need to know for the whole discussion. Asymmetric games. There are no identical strategy sets for both players. Sequential games. Players have several actions and no two players move at the same time. Imperfect information game. There is at least one action done that a player didn't know happened. Nash equilibrium. A player's action is the best response to the other player's actions. Players, the one who makes the decision or actions. Strategies, a set of two or more actions. Mixed strategy, a player acts according to a payoff distribution over his or her actions. Pure strategy, a player sets 100% payoff to one action. So, how does volleyball work? Volleyball is a sport played by two teams with 6 players on the court per team, each side of the court that is separated by a net. There are different versions of volleyball, but for this one, we are tackling indoor volleyball. The objective of the game is to send the ball over the net and prevent the ball from touching the ground. Once it touches the ground, the opponent gains a point. The team has 3 hits for returning the ball, block included. The game starts with the server who hits the ball over the net to the opponents. If the game continues to be in play, it is called a rally. The rally continues until the ball touches the playing court, goes out, or a team fails to return it properly. In volleyball, the team winning a rally scores a point, called the rally point system. When the receiving team wins a rally, it gains a point and the right to serve, and its players rotate one position clockwise. The defense for the game are the blocks and receives. The offense for the game are the serves and the spikes. A deuce is when each team's scores reaches 24 at the same time. A deuce is played until their score is 2 points ahead than the other. Hence, the winner for a set is equal to a quarter in basketball. The defense team players in volleyball are the middle blocker and libero. Note that the libero is substituting off a player back and forth, however, there must be at least 1 point played. The offense team are the setter, opposite hitter, and outside hitter. The setter is the one who delivers the ball to the hitters, also known as the spikers. So, the setter also plans on who would receive the ball, or he or she can also just dump the ball into an opponent's court, resulting to a point if it touches the ground. The opposite hitter is on the right side of the court. This player also digs and sets the ball, while the outside hitter is on the left side of the court and also supports the block of the middle blockers. Now that we've finished learning how volleyball works, let's discuss the unstable equilibrium of the sport. If an outcome is a Nash equilibrium, the player still cannot choose that strategy due to his or her rationality. but it also means that both players don't see any reason to consider the opponent choosing a mixed strategy due to fluctuating payoffs. It gets replaced by pure strategies. However, there are some points where players choose strategies that are very irrational, which leads to the sub-game perfect equilibrium. This equilibrium has payoff maximizing choices. The trembling hand equilibrium, on the other hand, is a small chance when the player's rationality breaks down, leading to a mistake or a wrong move. The predictability of a play in volleyball is a sequential game of imperfect information, because every decision of the player, not only must he or she consider the play of the opponent, but also his or her co-players on the court. The data processing of each player is limited. It can greatly affect the efficacy of a player. It is also tested by the response time. Like cell phones, there is a limited capacity of storage it has. The same applies to a player. If the player's space reached its limit, the other moves gets analyzed slower, thus affecting the reaction time of the whole team, eventually leading to losing a point. A selective selection, on the other hand, is when the player disregards the irrelevant information and focuses on the relevant ones. However, it has a downside. Further disregarding the irrelevant information leads to losing slowly the perception of which is irrelevant. The player leads to making wrong moves and processing less information. This can lead to the team focusing their attention to their player making wrong moves instead of focusing their strategy to use against the opponent. So now we will proceed to the hypothetical situations focusing on the predictability of a strategy. Here we have the situation we're in. The player with their co-players and opponent. Suppose that the team is aiming for a readable play on the player. Let P be predictable and UP be unpredictable. For the first situation, what would be the co-player's response if the player is predictable? So we can see here that 1 is the best response for the co-player, and it is tied. For the second situation, what would be the co-player's response if the player is unpredictable? This time it is unpredictable. The first situation is predictable. Once again, it is tied, being -1. The third situation is what would be the opponent's response if the player is predictable. This time it is the point of view of the opponent, and the player of the opposite team is predictable. We choose 1 because 1 is higher than 0. For the fourth situation, what would be the opponent's response if the player is unpredictable? It is tied by -1. We have the Nash equilibria of the ordered pairs. -1, 1, 1, -1, and -1 and -1, or unpredictable, predictable, predictable, unpredictable, and unpredictable, unpredictable. However, Nash equilibrium isn't used all the time by the players due to the rational thinking. They mostly result to dominant to dominant strategy equilibrium, since it has a better payoff than any other strategies and counterattacks. Here is the dominant strategy. For the opponents, P dominates UP because 0 and 1 are greater than -1. For the co-players, P dominates UP because 1 is greater than -1. Thus, the dominating strategy is P for the opponents and P for the co-players. In conclusion, it is better for both teams if the player is predictable. Since it is a cooperative game, the player must consider his or her co-player strategies as well as the opponents. Thank you so much for listening and have a nice day. Keep safe and hydrated, and God bless.